Hi everyone, and welcome to our first lesson on flipping the classroom. Today we're going to be learning about probability. I'm sure you guys have heard about it before, but before we get started on actually learning about it, let's think about what the actual definition of what a probability is. So we have the word event, and if we have the probability of an event, this is the measure of how likely the event is to occur. And another key part that goes to this is that its measure goes between 0 and 1. So it's measured and we also write it P of whatever event we are talking about. So as you can see here on this number line, we have it between 0 and 1 in fractions, and we have it between 0 and 1.0 in decimals, and 0 and 100% if we're talking about percents. And you guys should remember the conversions between decimals, fractions, and percents from earlier in the unit. But if you look here, we have some words over here. These are other key vocabulary words when we're working with probability. Now, if we're looking at the 0, when we think about 0, we would want to think that it is impossible to happen. So we're going to bring that over and put it under 0. And if we look at 1, if we know that something's 100% going to happen, we know that it is certain. So we're going to drag the word certain under 100. Now we're dealing with the numbers 0.25, 0.50, or 0.75. Now if we're going from impossible to certain, it seems that it would be in our best interest that likely is going to be closer to certain to happening, and that is going to fall right here. And unlikely is going to be closer to 0 or not close to 1. So then we're left with the term as likely as not, which means that there is a 50-50 shot of something happening. An example of that would be flipping a coin. You have just as many odds of getting a tails as you would flipping and getting a heads. So let's go on to the next slide. So I had mentioned earlier the word event, and our definition for event would be that there is a set of one or more outcomes that could happen. So let's write that down. And if you look down here, so the event could be, like we said earlier, flipping a coin, or another example of an event could be rolling a dice and getting a certain number. Like if I rolled a dice and I want to know what's the probability of getting a 5, that could be the event as well. So then the complement of that, the technical definition of it, would be the set of all outcomes that are not the event. So if you think about it, so let's say the probability of our event happening is 0.4. Then if you look at this formula down here, the probability of the complement or not the event would be 0.6. So if we had our event being 0.40 and 0.6, this would add up to being 1. So let's say that our probability of the event happening would be 30% or 0.3, and we know it has to equal 1, we know that the complement, or anything besides that event we're looking at, the probability of it not happening would be a 70% chance. So let's go and look at some examples here. We have our first example, and we're going to determine whether each event is impossible, unlikely, or as likely as not. So, and these are the words that we learned on that first slide. So let's say, look at this first one. It says rolling an odd number on a 6-number number cube, so like on a die. And the possible odd numbers are 1, 3, and 5. And the possibilities of it not being odd would be rolling a 2, 4, or a 6. I have 3 chances of getting an odd number, and I have 3 chances of getting a not odd number. So we know that rolling an odd number is as likely as not rolling an odd number because half of the outcomes are odd. If we go down to number 2, if I want to know the probability or whether it's possible, impossible, possible, or as likely as not of rolling a 4 on a 6-number cube. So the only way that I can roll a 4 is if it lands on the 4. And the complement of it being 4 would be 1, 2, 3, 5, or rolling a 6. I have more chance of rolling a not 4, or the complement of my event. So rolling a 4 is unlikely because only one of the outcome is a 4. Let's look at our example 2. We have a bag that contains 6 red marbles, 4 blue marbles, 2 green marbles, and 3 orange marbles. The probability of randomly drawing a green marble is 2 out of 15. And they get that because they added up all the possible outcomes, which goes on the bottom, and the event, or what you want to get, is on the top. So the probability of randomly drawing a green marble is 2 out of 15 because 6 plus 4 plus 2 plus 3 is 15. So this is all the possible and this one right here is our event. So we look down here, our formula that we saw earlier, the probability of our event plus the probability of our complement equals 1. So once again, we're looking at what's the probability of not drawing a green marble. So that would be our complement. Well, we know what our probability of getting a green is, and we know that we have to add up to get to 1, so we can set up our equation like so. So what we're going to do is we're going to substitute our probability of the event, so 2 out of 15, and we're going to put that in there. And we know that this is our unknown, and this is what we're solving for. So we're going to subtract 2 out of 15 from both sides, and we're going to get probability of not green left on this side of the equation, and 13 out of 15 on this side of the equation. So the actual probability of not drawing a green marble is 13 out of 15. So it is definitely much more likely to draw something that is not green than if I wanted to draw a color that was green. This should help you with the lesson and activities that we're going to do tomorrow. And feel free to email me if you have any questions. Otherwise, I will see you tomorrow.